All right, so now that you've gotten your right triangle book filled in, there are some examples in your example packet that you want to make sure that you understand how to do, so we'll walk through those really quick. So first, our Pythagorean theorem. Anytime we've got two sides, anytime we know two sides of a right triangle, we want to find the third, we want to use that Pythagorean theorem, right? So here, how high up on the wall will a 20-foot ladder touch if the foot of the ladder is placed 5 feet from the wall, right? So in all of these examples, you're going to want to stop the video, give yourself a couple of minutes to work through these, and then start the video back up. And this is just you doing your own practice and checking to make sure that you're getting it right, okay? All right. So I always want to draw a good picture. So up a wall, so there's a wall and a ladder that's reaching a 20-foot ladder. So this is a 20-foot ladder reaching up a wall, and it's 5 feet from the wall, right? And we want to know how high up the ladder reaches. Well, we've got two. And this is going to be a right triangle because the wall, of course, is going to be built perpendicular to the ground. That's typically how we build our walls. And so we've got two sides of a right triangle, and we want to use Pythagorean theorem to find out how far up the wall it reaches. So the hypotenuse is 20, so we're going to 20 squared. It needs to be equal to 5 squared plus x squared. Right? So 400 equals 25 plus x squared. Subtract 25 from both sides. Then we're going to square roots. And yeah, normally we want to reduce our radicals, but here it would make more sense to go ahead and get a decimal since we're talking about how far up a wall something is reaching, and so it makes sense to talk about it in a decimal form instead of a radical form. So how far up that wall is it reaching? Turns out 19.4 feet. Okay? All right. The next one. Find the area of the rectangular rug if the width is 12 feet and the diagonal measures 20 feet. Sketch a good picture. Remember how to find the area of a rectangle. Go to work, and then you start the video back up and make sure you're right. Okay, so there's a rug. The width is 12 feet, and the diagonal is 20 feet. Well, in order to find the area of a rectangle, we need length times width. Right now, we know the width is 12 feet. We just need the length, right, which would be this guy right here. Well, again, it's a rectangular rug, so this is going to be a right angle down here. So we can use Pythagorean theorem again. We can go 20 squared equals 12 squared plus x squared. So 400 equals 144. Subtract 144 from both sides. Square root both sides. And the length is 16 feet. So 16 times 12 ends up giving you 192 square feet. Okay, so hopefully you got that. If you're not getting these, make sure you come in and get some help. All right. Find the area of an isosceles triangle. Now, before you get going here, you're probably going to want to understand something. In an isosceles triangle, right? Isosceles triangle means that these legs are congruent. Right? If we drop an altitude down, so from the vertex angle down to the base, this is an altitude. It's going to be at a right angle. We want to do that because if we want to try to find the height of a triangle, which we're going to need to do in here, that's the height. The height's at a perpendicular always, so the altitude from the vertex angle down to the base would be the height. Watch what happens when you drop an altitude down to an isosceles triangle, right? Now we've got two right triangles because of that right angle right there. By reflexive, the altitude is going to be congruent to itself. And so now we've got two right triangles, 1 and 2, that are congruent to each other, right? Because of hypotenuse leg. Because these two triangles are congruent to each other, then by CPCTC, the pieces down here, these two sides right here, are going to be congruent. So what that means is that when you drop an altitude down into an isosceles triangle, that altitude is going to bisect the base. Okay? So when we tell you that there's an isosceles triangle whose sides are 10, 13, and 13, and we drop the height down, or the altitude down, then as the diagram shows over here, it's going to take that 10-meter base and cut it in half, 5 and 5. But the base is still 10. Remember, the base is still 10. Right? So that should give you everything you need to know to find the area of this triangle. So stop the video, give it a shot, and then start it back up and see if you're right. All right. So the area of a triangle, 1/2 base times height. Right now we know the base is 10, but we don't know the height or the altitude. So helpful that when we drop this altitude, then the two right triangles have sides 5, 13 for the hypotenuse, and then h, right? So we can use Pythagorean theorem here to find that height. Just use 5, right? Because we're talking about just using one of the right triangles. This is going to be 169 equals h squared plus 25. And so this is going to be 144 when you subtract square root, and h is going to be 12. So the height's going to be 12. So you plug that into your area formula, and you discover that the area is 60 meters squared. Okay? All right. Last but not least in the Pythagorean theorem thing here. Find two methods. Use two methods. We talked about Pythagorean triples in your book, and you could have used a triple on the last problem. Actually, two problems that we've done so far. And you can actually use Pythagorean triples here as well. If you divide both of these guys by 2, then you get 5 and 12. And 5, 12, 13 is one of your Pythagorean triples. Which means that to find this side, all we got to do is take 13 and multiply it by 2. Which will give you 26. Okay? That's quick and easy. Otherwise, you can just use Pythagorean theorem. Right? Hypotenuse squared equals leg squared plus leg squared. So you get 576 plus 100. 676, which should give you 26, and it does. Okay, so two ways. And again, Pythagorean triples are nice if you remember them, but not absolutely necessary. Okay, all right. Then we talked about the converse to Pythagorean theorem, checking to see if side lengths make a right triangle. If they don't, then it'll actually tell us what kind of triangle it would make, right? Obtuse or acute, right? So a quick reminder of the converse to the Pythagorean theorem: if the lengths of the three sides of a triangle satisfy the Pythagorean equation, then the triangle is a right triangle. So we're given these two sets of side lengths here, and your task is to figure out if this is going to make a right triangle or not. Quick reminder, you're going to want to check to see if it even makes a triangle, right? And so the two shorter sides have to add up to be bigger than the third. 8 plus 15 is 23. 23 is definitely bigger than 17. So in this first example, it does work. In the second set of numbers, 12 plus 35 is 47. 47 is bigger than 36, so it is going to make a triangle. Now go find out if it's a right triangle. So go ahead and stop the video. Use what we did in your book, and then start the video back up to see if you're right. Okay, so to check, if this is going to make a right triangle, then the hypotenuse has to be the longest side. So that means that the 17 would have to be the hypotenuse and therefore be the guy that goes by itself in the Pythagorean equation. Right? So if you set this up, you get this, and then you get 289 equals 289. So yes, this is a right triangle. The other guy, 36, would have to be your hypotenuse. So this is how you'd have to check. So you get 1296. Add the 144 and the 1225, and you get 1369. So no, not a right triangle. Which, since the second set of numbers doesn't make a right triangle, again, like we talked about in your book, the next best question would be, okay, what kind of triangle does it make, obtuse or acute? And we talked about that. Since the hypotenuse squared, or can't call it the hypotenuse because this is not a right triangle, but the longest side squared actually ends up being less than the other two sides squared and added together. So that would actually make this guy an acute triangle, right? I know it wasn't part of what you needed to do, but a quick reminder there of how you can tell if it's an acute or obtuse triangle. Okay? So you've got a couple sets of numbers here. So now you try, figure out if these side lengths are going to make a acute or obtuse triangle. And a quick check to make sure that these side lengths even make a triangle is what you're going to want to do, right? So go ahead and stop the video, walk through that, and you can start it back up and see how you're doing. Okay, so the only thing you got to be careful of here is recognizing that 6 is the longest side and not the square root of 8 in this first set of numbers. Because if you were to actually type in the square root of 8, it would give you about 2.8. So those are your smaller sides. The square root of 8 and 4 are your smaller sides. And if you add those together, you get like 6.8, which is definitely bigger than 6. So we do know that these side lengths are going to make a triangle. Now we just got to figure out what kind of triangle they do make. So we got to take the longest side, square it, and then I'm not going to put in an equal sign because I'm just going to compare them, right? See what happens. So this is going to give you 36. This is 16. Now the square root of 8 squared is just 8. The square and the square root cancel each other out. So 36 is bigger than 24. So this is not going to be a right triangle. It's actually going to be obtuse because the longest side squared is bigger. That's our rule. Okay. Second set of numbers, obviously 20 and 21 are their smaller sides. They add to 41. Definitely bigger than 28, so these guys will make a triangle. We just want to figure out what kind. So longest side squared by itself, and then the other two sides added together when you square them. So you get 784 here, 400 here. So you go 784 and then 841. So the longest side squared is less than, so this is going to be an acute triangle. Okay? All right, so hopefully you got all those right. Everything makes sense. If so, go ahead and knock out your homework, which is sitting in Canvas. Otherwise, come on in and get some help.